Cool. So we may as well close the door so that when they move the trolleys, it will be acceptable. So welcome to our Beyond Language session, sort of aligned with this morning's Filian's keynote. Remember the weird things that programming language syntax does versus the more normal natural language? It's probably more aligned with that for all the three talks. So first we have Assaf on could no code be code, and we'll just give people a moment to sit down and carry on.
Okay. Could no code be code? In this work we present our onward vision toward a no-code programming language for citizen developers. I am Assaf from 2.software, and this is a joint work with David Lorenz from the Open University of Israel. There are a lot of programming languages today. But it's time for a radical change. Why is that? Because software does not meet its challenges. By 2025, in a year from now, or a year and a half from now, for every filled programmable position, there will be one unfilled, and in 2023, the situation is worsened, there will be two unfilled. This is causing already a 1 trillion year in financial losses for companies. And this is like the revenue of Apple and Amazon combined. It's a huge amount of money. So this brings, the scarcity of programmers brings citizens to the stage. In 2022, last year, in large corporations, there already were 4 citizens for every programmer. Which tools do these citizens use? Low code and no code. However, as IEEE has stated, each of these tools solves a subset of the needs. They are not flexible, resembling hardware or modern software. They may provide some programming capability, but they are not a GPL. So there's a gap between the current tools and the citizens' actual needs. You may say that their programming skills are low, but this does not mean that their software needs are low. In fact, from the experience we gained with citizens, I can tell you that their needs are no different. They need flexible algorithms, they need complex data structures, they need a GPL. In this work, we present a powerful no-code GPL. No-code means that the entire development is done by mouse actions only. That is, without typing a single line of code. In addition to no-code GPL, this language has some more important properties, such as cloud development, which means that you don't only develop the program in the cloud, but it also runs in the cloud. And if you have a team, if you have a team, then it means that you know exactly what your team is doing right now. Collaboration, like in Google Sheet and the Google Docs. You can sign in and help your colleague program and overcome an obstacle. Sharing. This means that in a click of a button, you can post your new creation to the cloud, and the platform automatically sanitizes the code from domain-specific information. Live programming means that you can select a specific function or a rule and activate just this function. Native tongue. If you look at English proficiency survey, you'll find out that there are many countries, many modern countries, that are in the moderate or even low group? Why leave so many good citizens behind? Our language can speak their native tongue. And visual coding means that the flow control can be developed with a flowchart. And this is more appealing to citizens. So the motivation. At this point you may be asking yourself, but how could it be? How could no code and GPL coexist? They are in two different worlds. In one we have citizens with domain-specific solutions that are simple to develop but are very inflexible, hard. In the other we have programmers with general-purpose solutions that are complex to develop but are very flexible, soft. In fact, if we take the good things from both worlds, we can get a no-code GPL. Programming languages are indeed complicated, but it's not anyone's fault. It has been so for 70 years, since Corrado Bohm invented the first compiled language. You can see in this table that programming languages are still created. Look at TypeScript and Rust from the last decade. However, they are not attacking complexity. Rust, which is gaining popularity nowadays, is one of the most complicated. One notable exception here is Go. One of the goals of Go was to make it simple. The three inventors had an agreement. Each had the right to veto new features. So this kept Go about 2 times smaller than Java and C++ that were used in Google at that time. And this was achieved by 3 superb engineers. One, a Turing Prize winner, Ken Thompson, who invented Unix. So if Ken came in the morning and said, "Hi guys, I've got a wonderful idea," the 2 other guys sent him back, "Come tomorrow with another idea." In a talk titled "Simplicity is Complicated," Rob Pike explains the many complications they had in making a simple language. We continued in this direction and created a new language which is 10 times smaller than Go. Just look at the 2 yellow lines. I want to make an important note here. This project was not motivated by curiosity. It was not that I had nothing to do at home and thought, it would be a great academic challenge to see how far we can get making a simple language. No, this was done already 30 years ago by Urban Müller, who invented brainfuck with only 8 commands. This is how the Hello World program looks in brainfuck. Is this appealing to anyone? So, being small does not necessarily mean being simple. We wanted to create a language that will be simple, will be small and simple. Easy to read, easy to learn, and easy to program. This project took 5 years. It's like another PhD for me. My son helped me in the early stages, had a great contribution. And I'm telling you this because it took a long time to, as Steve Jobs said, to dig into the complexities and understand their nature, to be intimate with these complexities. Only when you understand the complexities, you can get rid of things that are unnecessary. So the first version of 2, this is the name of the language, things object-oriented. The first version simply failed to fly, but now we feel that we have a aerobatic plane. So language design. Look here at the 10 syntax rules of 2. Compare it with the 1400 rules of Java. Let's see a simple example. Let's see what's behind this naive hello program. You see here the hello thing, and it contains a terminal and one rule, notifies up, that is triggered by the runtime system when hello is up and running. So when hello notifies up, the terminal print Qashqaish. Let's make it a little more complicated. Here we see already that print is variadic. It takes let's see the terminal thing. You can see the print function. It takes a variable number of string interfaces. An interface is defined as in Go and as in other languages. Look here at the 2023. It's a number, but it's printable. It's printable because the number thing implements the asString function. Similarly, the hello thing itself is printable since it implements the asString function. So, the result would obviously be Qashqaish 2023 hello world. I want to make a note here. See, the print function is intuitive, but it's intuitive. You can throw anything and it will be printed. But 2 is not, just a minute. Two is not dynamically typed. It would be disastrous to have a dynamically typed language for citizens. 2 is strictly typed. And this means that the conversions that you saw here are resolved already in compile time. Before showing what's in 2, I'll go briefly of what's inessential in 2. So we saw already that keywords are inessential. Basic types such as int and float are simply things, so they are not part of the language. Binary operators are all replaced with functions. Variable declaration, global, pointers, and import section are also unnecessary because in 2, we want to comply as much as possible with the rule-based abstraction. And in a rule-based system, for example, think of a checkpoint router with a firewall, you cannot find their variable declarations, globals, and stuff like that. Let's see what inside. Things-based. This means that everything is made of thing, and this is again because thing or object is an abstraction appealing for citizens. Event-driven, again, a simple abstraction that citizens understand. When something happens, do this and that. Component-based means that it's open for third party, and it uses plug-in. So hot plug-in means that if I have in a factory, I have a conveyor, and I have a feeder, and I want to replace something in the feeder, I can leave the conveyor working. Marketplace is where all the things that were ever posted for sharing is handled. And citizen-oriented, let's see in more detail what is that. So, this is the IDE, or as we call it, CDE, because it's cloud development environment where things also run. This is the compact citizen view. This is the expanded citizen view. And this is the classical programmer's view. So you see that the program is segregated into 2 sections of data structure and algorithms. And the algorithm section is further separated into rules, functions, and events. This is in contrast with most GPLs where you have all these sections intermixed in one monolithic piece of text. And we think that this may be will be appealing for citizens. Data structures. 2 does not have multiple data structures, only one. And it does not have nested data structures. See, for example, this course thing. It has 2 arrays. One of numbers, student grades, and another array of student names. We can replace these 2 arrays with one student array. And the student thing will include these 2 fields, grade and name. Expressions. In Go and in many other languages, you have lots of operators. In 2, we replace them by functions because citizens are not necessarily practicing development daily. They can come back after 6 months and they should understand what's going on. So we're not expecting that they will remember all these cryptic symbols. Fluent style chaining. If you were to read this over the phone to someone, how would it sound? A plus B times C squared, right? This is how you write it in 2. A plus B times C squared. Concurrency. In Go you would write Go start, and in 2 you would write Go run thread. And I don't think that we compromise here anything for readability. Write assignment. These 2 lines calculate the volume of a cylinder. This is the assignment operator. If I read this, it would be assign something to base or assign something to volume. The roots for this comes, of course, from the math language where we have y equals f of x, but math equality is not an assignment. It would be therefore counterintuitive to put base and volume on the left. In 2, we do it this way, where the arrow stands for Go to. And advanced citizens would write it like this. So it's math pi times radius squared goes to base times height goes to volume. Autodependencies. This is our cylinder with mass and 2 numbers. But where are the dependencies? Well, in 2 we don't have dependencies. They are not part of the language. Instead, they're taken care of by path distances in the directory tree, and directory is again an abstraction known very well to citizens. So for example, if the cylinder is implemented under Assaf geometry and the math and number are in 2 core, then the cylinder will depend on them. But if now I decide to create my own version of math under Assaf geometry, it will be selected instead because it's closer. If later on I decide to revert back to the version in core, then I must use an explicit path. Control flow. In Go and other languages, you would use a keyword, if something, and in 2, you would use the question mark. Iterative statement. In Go and other languages, you would use the for statement. In 2, you simply prefix the action with a star. Anything you prefix with a star would run iteratively. Wildcards. In this loop, we sum up the elements of list into sum. This is how it would look in 2. Sum add to it the elements of list, and this is the wildcard operator. So now for the demo. At the top, we see the programs that I'm working on right now. Here we can see the different views that I talked about. The expanded view, the classical or the classical programmer's view, let's go back to hello and make some changes. Let's run it. Qashqai's 2023, hello world. Now let's make a small change. Let's add another line with the current time. So for that, we need to bring in the time thing. The time thing is found in 2 core. And let's create a new action. I can create a conditional action. But now I need only this action. So again, we need the terminal thing. And the print function. Oops, I have here a red plus. This means that this line won't compile. And of course it won't compile because print function requires at least 1 parameter. So let's bring it in. Time. Now, let's run it again. So you see the current time. Well, I'm off schedule. I should be hurry. It's 16:21 in Israel. Okay, just a minute. So back to evaluation. We evaluated 2 in 3 scenarios. So in one scenario, 2 was deployed in a large agriculture farm with 15 indoor growing rooms. A lot of money was spent on this agriculture farm, and in this farm we control various aspects of the growing rooms, such as electricity, cooling and heating systems, temperature, humidity, CO2. This system currently handles 100,000 events daily with 100 instances and 25 components. In another setup of a factory that we tried this year, once the IDE was completed, we had a system in a lab scenario with a mixer and a boiler, and this was done by a citizen supervised. And in the third scenario, this was an office automation scenario. We tried it with 6 citizens that had to program unsupervised after watching a video. They had to create something fairly small with only 2 rules. So the lessons learned. Programming, I'll start from the cons. Programming is fairly difficult for citizens. It's not trivial for them, it's challenging. What seems to be trivial for us might not be so simple for citizens. For example, they had troubles in finding the right objects for the task. They had problems with fluent style chaining, which is not known to them. They know perhaps Excel and Google Sheet, but they don't know fluent style. They had problems with the Boolean algebra, because they are not educated with Boolean algebra. The good news is that they can program. Citizens do explore their programming freedom. The playground that we have plays an important role where they can gain confidence. They have no penalty there in making mistakes. And mentoring is very important at early stages to ramp up, get to speed with development. I leave the related work for reading. Conclusion. So we saw software is not meeting the challenges. A new paradigm of no-code GPL is needed. We created a tiny GPL at the core, and with the CDE on top of that, the IDE on top of that, this enables to democratize software use. We show a powerful no-code GPL with many properties that you can find more about in the paper. Future work. Lots of things need to be done. I will not go into these things deeply now. A debugger. Citizens do not know the word debugger, let alone how a debugger works. So you have to think carefully how you create this project to make it simple for them. Documentation framework, very important, and so forth. Citizens need a lot more need to be done, and we can all join forces and help them make a successful entry to the programming world. Our contact is also simple, 2.software.
Thanks, Assaf. We have a few minutes for questions. We're in a very tiny room, so we can run around.
Hi, thanks for the talk. First, a small kind of question, observation, like COBOL, back in the days, it was also a language very verbose, like there was no operators, everything was very literal, like the add and the plus, but somehow that style didn't prevail. So how come you are so convinced that writing add and plus is better than writing the operators?
Good question. It all depends on the projection. So you can decide. We have the AST inside. So
you allow both.
We can project it back with plus and minus and even binary operators. It's no problem. So what I'm saying, is it's just a matter of projection.
Yeah. Okay. And if I'm allowed, how do you relate? Maybe you discussed that in the paper, but how do you relate that what you are proposing with tools such as OutSystems or Mendix, which are also general purpose tools, which people without background in informatics, they are able to use? Do you know those tools?
The truth, I'm not familiar with these two.
Okay. But they are, OutSystems, Mendix, they're quite famous no-code tools, so I think you should contrast, because they're also general purpose, so somehow they are achieving a similar thing. Okay.
I'll look into that.
So if experienced programmers mess up and introduce bugs, I would say that getting a program right for a citizen would be quite difficult, right? What kind of tools do you see that could help to get programs right? So not only debuggers, as you said, are too difficult, but what kind of tools would help getting in an iterative phase to a correct program?
So I think this is a good question, because programming is difficult and you cannot change it. So we see a lot of documentation, and once we have a marketplace where people can post programs, I think that the programs that will be chosen, you can put a price tag on your program, and people will choose it not just for price, but also for documentation. So perhaps there will be a video there, and you'll be able to see how to do things in the right way. So you'll have, as a citizens programming, you'll have to learn a lot. You have to see a lot of videos, short videos that people prepared for you in the marketplace. Otherwise, you can also get some assistance by mentoring, but it's difficult.
So last question.
Okay, so how do you compare with the Smalltalk? Like in general, the people from the Smalltalk community were first made a very core, elegant language, and then they spend massive amount of effort into trying to make graphical support of various kind to promote its usability. In some sense, your project seems to be a recreation of the Smalltalk experiment?
Well, Smalltalk is really a good example because it's really a small language, but I think that what we've created here is something that was focused on citizens, all the way thinking about citizens. Citizens in mind makes you come up with something a little different. Okay? Thank you.
All right. Thank you very much.